Alright, so I was looking through you guys' homework, and I saw some questions that you guys had from stuff from Chapter 16. If I've missed any questions you had from any of the other chapters or from anything that we have coming up, please let me know. Just send me a message and let me know that so that I can make those videos. I've been trying to pay closer attention to stuff since we got Google Classroom up. It's a little easier to see everything at once and kind of follow up on any questions that you guys might have. But for now, I'm going to do some stuff from 16 and a couple things from the quizzes on there. And then I do have the answer keys for you guys. I'm working on them. I just need to get them scanned in. So hopefully I can do that tomorrow, but we'll see. So the first question that I remember was from 16B, and I didn't see a specific problem number, so I chose 16B number 1. Okay, so this says that we have, and this is on page 568, we have 3-point charges, Q1, Q2, and Q3, which lie along the x-axis at x is equal to 0, x is equal to 3, and x is equal to 5, respectively. Calculate the magnitude and direction of the electric force on each of the 3-point charges when Q1 is equal to positive 6.0. I think that's coulombs. UC. Yeah, okay. Q2 is 1.5 and Q3 is negative 2. Okay, and so on. So, try to give a little bit of background to this problem first to try to help us understand it a little bit better. Ultimately, you probably don't need all this information I'm about to write down, but just to try to give you guys a little bit more insight into what's going on here. So basically, we have this superposition principle. Which states that the force on each particle is the vector sum of the force, or forces, I should say, exerted on it by all nearby charged particles. So, in this particular problem, all of our charges are on the x-axis. So we don't really need to treat this as a vector problem. Words running together. All right, so what we do want to do now is to actually start looking at the problem. We want to, first of all, use Coulomb's law to determine the force each charge exerts on another charge. So we'll be using the formula F is equal to K sub C times Q1, Q2 all over R squared. Okay, and these 1 and 2s obviously will end up being other numbers as well since we have 3 charges that we're dealing with. But our given is that we have when x is equal to 0, Q1 is equal to 6.0 UC. X is equal to 0.03 meters, and I went ahead and just changed them into meters. Let's see, Q2 plus 1.5 UC. Okay, and these, the signs, I don't know if I pointed this out, but this is direction. So the signs, I mean, they're relevant, but they're not actually relevant when you put them in the problem. And then X is 0.05 meters. Q3 is minus 2.0 UC. All right, so we need to evaluate a couple different how do I want to word this? A couple different relationships, I guess, is the best way to say it. So we have that we want to know f of 1, 2. I want f of 1, 3. And I want f of 2, 3. So remember the Coulomb constant is 8.99 times 10 to the 9th. Okay, and it's got units on it. For the sake of space, I'm not going to write all the units in, but if you wanted to write your units in to check and make sure everything's canceling out, you can. So we get here 8.99 times 10 to the 9th times 6.0 times 10 to the negative 6 times 1.5 times 10 to the negative 6 all over, okay, and that's because of this here. That's why it's 10 to the negative 6. Then 0.03 squared is equal to, this comes out to be, when you type it in your calculator, I've already done this just to make it go by a little faster, 89.9 newtons. Okay, but when we actually go down and use this, the book does go ahead and round your numbers off. So we're going to go ahead and call this 90. Normally, I'm very against rounding at this point because we're not done. However, the book goes ahead and uses rounded numbers, so we're just going to go ahead and round it. Oh, so f of 1, 3 with 8.99 times 10 to the 9th. And then we have 6.0 times 10 to the negative 6 times 2.0 times 10 to the negative 6. This is where I was saying the negative doesn't matter. We don't actually write that in here. It's just telling you a direction. It's a direction vector. So 0.05 squared is equal to 43.152, which then we round off to 43. And then lastly, we have f of 2, 3, which is 8.99 times 10 to the 9th. 1.5 times 10 to the negative 6 times 2.0 times 10 to the negative 6 all over 0.02 squared. 67.425 is equal to 67 newtons. All right, so then we need to think about what's actually happening in each case so we can get our signs correct in terms of our directions here. So Q1 and Q2 are both positive, so they repel, meaning that for F1, 2, it acts on Q1 to the left and on Q2 to the right. And we'll use this in just a second. Let's go ahead and do Q1 and Q3 are opposite charges. So F13 acts on Q1 to the right and on Q3 to the left. Then Q2 and Q3 are opposite charges. And so they attract, which I should have said about these ones up here. So then F23 acts on Q2 to the right and on Q3 to the left. So then our FNet 1 is negative 90 plus 43, so that's these two here, which is negative 47. Yeah, negative 47 newtons to the left. Well, let me rephrase here. Hold on. I should either say negative 47 newtons or I should say 47 newtons to the left. Your book says on the negative x-axis. So it's up to you how you want to write it. I would, I'd be fine with any way that you wrote it. It wouldn't be wrong either way. FNet 2. 90 newtons plus 67 newtons. So this one is 157 newtons to the right. And lastly, FNet 3 is negative 43 newtons minus 67 newtons. Which then is equal to negative 110 newtons to the left. Or, well, like I said, should say 110 to the left, or I should say negative 110. But these are the answers for this problem here. So hopefully that kind of helped you guys out a little bit. Then, let's see, the next question we had was from C. And so I chose number 2. So it says, a charge Q1 of minus 5 times 10 to the negative 9th coulombs and a charge of charge Q2 of negative 2 times 10 to the negative 9th coulombs are separated by a distance of 40 centimeters. Find the equilibrium position for a third charge of positive 15 times 10 to the negative 9th coulombs. So, first thing I would do here is to draw a picture. Kind of just like a diagram of the equilibrium position. So this is 16C2. So diagram of equilibrium position. So we end up with R X minus R. So then, which I probably should have actually drawn these first, but you have Q1, Q3, Q2, and so on. And the distance between 1 and 2 is 40 centimeters. Alright, so the equation for let's see, electric force between Q3 and Q1 would be F31 is equal to K sub C Q3 Q1 over R squared. And then between Q3 and Q2, is F of 32 is equal to K sub C Q3 Q2 over R squared. So then I'm looking for the equilibrium position, so I'm going to set these two equal to each other. So F of 3,1 is equal to F of 3,2. K sub C Q3 Q1 over R squared is equal to K sub C Q3 Q2 over R squared. So then I need to solve for, well, I'm trying to get R basically by itself is what I'm going for here, because that's what I'm trying to find is that position. So I want to get R by itself. So now I can get rid of the K sub C's here because they're going to go away, leaving me with Q3 Q1 over R squared is equal to Q3 Q2 over R squared. So then from here, because I have a Q3 in both of these, I can get rid of those. My Q's kind of look like 9s, so no, those are Q's, not 9s. Alright, so then this leaves me with Q1 over R squared is equal to Q2 over R squared. So I can swap these two here, giving me Q1, or wait. Sorry guys, I messed up and forgot. This is supposed to be up here. This one should actually be X minus R. So this should be X minus R, all that's, well, and then this whole thing is squared. I knew something wasn't right. I was like, that just makes everything cancel. So there we go. Because this is, obviously we don't know what, this is R here is 3 to 1, but then we have to see what is the rest of it, which is why we're using X minus R. So maybe you caught my mistake, maybe you didn't, but that's what I should have done. So now I can get, actually I want to get this on top, so I'm going to swap these two. So I'm going to get X minus R squared over R squared is equal to Q2 over Q1. And now all this stuff is squared here. So to basically get rid of it, I'm going to take the square root of both sides, so giving me X minus R over R is equal to the square root of Q2 over Q1. I can rewrite this as X over R minus 1, which is equal to the square root of Q2 over Q1. And then I can add the 1 over, and then I can flip everything over. So I'm going to take this and I'm going to flip it to the bottom, okay, and put the X on top. So, well, here, let's just do this step by step. X over R is equal to the square root of Q2 over Q1 plus 1. And then because I want to solve for R, I'm going to take everything and flip it. So I'm going to end up with, let's go up here, R is equal to X over the square root of Q2 over Q1 plus 1. Now my Q's look like A's. So then R is equal to 40.0 centimeters times 1 over 100 centimeters. Okay, I want to convert it into meters. All over the square root of minus 5.00 times 10 to the negative 9th coulombs over minus 2.00 times 10 to the negative 9th coulombs, and then plus 1. So this ends up coming down to be 0.40 meters over, worked on the calculator, this should be 1.632 approximately, which then gives us 0.245 meters for our R value that we were looking for. So hopefully that helps with that one. I will say these book ones are a lot harder than the ones that are on the quizzes we're about to go over. So if these are still confusing, don't stress out about them too much. But let's look at these problems out of the quiz. So I'm going to put up the paper here and just work it at the bottom so you can see a couple of those answers are there from the other one. So this is the 16.21, or the one that's called electric force, I believe. Yeah, it's this one. So let me actually grab my red pen just so that my key is all in red. Alright, so with this one, just because we have a lot less going on, okay, it's not going to be as in-depth here. I will go ahead and write out all of the givens for this one. So we have Q1 is 4.0 times 10 to the negative 6 coulombs. Q2 minus 8.0 times 10 to the negative 6 coulombs. R is 2.4 times 10 to the negative 2 meters. And K sub C is 8.99 times 10 to the 9th. And ultimately, I want to know what my electric force is. So that's what I don't know yet, but that's what I want to find. So my formula is F electric is equal to K sub C, Q1, Q2 over R squared. So it's a formula that we would use a lot. So this is 8.99 times 10 to the 9th. Oh, and these units are newtons times meters squared per coulomb squared. Just for the sake of space, I'm not going to write in the units because I wrote them all up here. So times 4.0 times 10 to the negative 6 times negative 8.0 times 10 to the negative 6 over 2.4 times 10 to the negative 2. And so then typing all that in the calculator, you should get F electric is equal to minus 5.0 times 10 to the second newtons. Okay, and with this, that just means it's going to the left. Okay, that's all that negative sign means. So if we write the negative, we don't have to write any more information about it. But that's that one on the quiz. And I do have a lot of these keys done. I just need to send them out to you guys. So hopefully I'll get that done the next day or so for you guys. Alright, and then 16.3, so this is the electric field problem. So we have an electric field to produce a charge. For this field strength, what is the distance of the charge? Okay, and obviously we have our Q sub C. So our givens, again for this one, we have E is equal to 2250 newtons per coulomb. Okay, and that's the electric field. Q is 4.82 times 10 to the negative 11th. K sub C 8.99 times 10 to the 9th newtons times meter squared per coulomb squared. And ultimately I want to know R. So, the formula is E is equal to K sub C Q over R squared. But I need to know R, so I need to solve for this so I can divide by K sub C and Q. Or actually, I can just flip the R and the E. So R squared is equal to K sub C Q over E. And then R is equal to the square root of K sub C Q over E. So now I can just take stuff and plug stuff in. So this is 8.99 times 10 to the 9th times 4.82 times 10 to the negative 11, all over 2250 newtons per coulomb. Oh, well, I didn't write the units on the rest of them, so I'll just get rid of that. So then this ends up equaling 1.39 times 10 to the negative 2 meters. So that's the answer for that one. So hopefully this stuff helps you guys out with that section. Like I said, if there's questions about other stuff that I just didn't catch, or once I send you the keys, if you're like, snap, I didn't do that right, whatever, just let me know. I know that you guys have other classes that you're really focusing on, which is why I've tried to make this class just kind of more chill, a little bit easier, just, you know, mainly some worksheets and stuff, to try to help you guys out in that respect. But if you are interested and you want to know how to do something, just let me know, and I will do my best to get it out as quickly and accurately as possible. So have a great day.